Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the May-June 2022 9709 Cambridge A-level paper. This is variant 1-3. This is the pure mathematics paper, and here we have a question about a curve which has equation y equals x squared plus 2x minus 5. It's translated by the vector minus 1, 3. You're going to find the equation of the translated curve, giving your answer in the form y equals ax squared plus bx plus c. So the easiest way to deal with this question is to basically deal with the transformations that have taken place one by one. So there's two things happened. One, it's been translated horizontally by minus 1, 0. Okay, so that will cause a change in the graph such that you replace the x with x plus 1, because this is going 1 unit to the left. Okay, so you replace the x with x plus 1. It's like the opposite. Okay, and the second thing that's happened is you're going to have it's going to go up by 3. It's going to be, a vertical translation of 3 units. So that will cause it to then become fx plus 1 plus 3. Okay, so that's what these two combined give us. So this part here contributes to this happening, and this part here contributes to that happening. So basically, in the graph, what we have to do, we have to replace the x with x plus 1. So we'll have y equals, instead of x squared, it'll be x plus 1 squared, plus 2 times, instead of x, we'll have x plus 1, and we got minus 5, and then we have to add 3 to the whole function. So you add 3 to the whole function. So this will be the equation of the new curve, but we want to write it in this form, so we have to expand and simplify. So you expand this bracket, it gives you x squared plus 2x plus 1. Expand this, you're going to have plus 2x plus 2. Minus 5 plus 3 is minus 2. Okay. So now we'll end up with those two cancelling out. You're going to have y equals x squared plus 4x plus 1, and that is the equation of the curve in the form required. Now for part B, it says the curve with equation y equals x squared plus 2x minus 5 is transformed to a curve with equation y equals 4x squared plus 4x minus 5. Describe fully the single transformation that has been applied. Now, if we just observe what's happened here, the minus 5 hasn't been changed. So we can't say the whole thing has been multiplied by something, or you've added or subtracted something from the whole function. The only thing that's changed are the x's. The whole function hasn't been changed. The x's have changed. And how would we end up getting 4x squared plus 4x from this? I can kind of spot it right now, that if we replace the x with 2x, this is going to become 2x squared plus 2 times 2x minus 5. So we end up with y equals 4x squared plus 4x minus 5. Okay, so we can see that we have found the transformation, which is a horizontal. This is a horizontal stretch. Okay, because you're multiplying, it's multiplying something, but you're multiplying inside the function. It's replacing the x with 2x. So therefore, it kind of does the opposite. So it's going to be, the scale factor is going to be not 2, it's going to be the reciprocal of 2, which is a half. So that is the single transformation which has been applied for this to become that. Okay, now one way we could, that's enough for the answer. That's it, we've got it, finished. Don't have to do anything else. Okay, if you can spot that, that's fine. Now some people might think, oh, let's complete the square for these and then see what happens. They might want to start like that. So if you did start like that, you would have y equals x plus 1 squared minus 1 minus 5, which gives you y equals x plus 1 squared minus 6. And if you completed the square for this, well, this is a perfect square, 4x squared. So I could do it in this way. I have 2x. Okay, now I'm going to have plus. Now these two numbers multiply to give me, these two numbers doubled multiply to give me the middle term. So 2x times something, okay, equals 4x. So 2x times something doubled, okay, times something, times 2 is going to give me 4x. That must be a 1. So that's 2x plus 1 squared. That's going to give me 4x squared plus 4x. But then I have to take away the 1. And then I've got minus 5. So this gives me y equals 2x plus 1 squared minus 6. So we can see the only transformation that's taken place here is that you multiplied the x inside the function by 2. Everything else stayed the same. Horizontally, that's 1 plus 1, stays the same, the translation. Vertically, minus 6, they're in the same place. They don't change in relation to each other. But the only thing that's changed is the x became 2x, so it's a horizontal stretch of scale factor a half. So that confirms what we just said. Now, some people might have completed the square differently here, which is also okay. So let's see what happens if we did that. If they took out the 4 and they wrote x squared plus x minus 5, then they completed the square for what's in here. So you have 4 times x plus 1 plus a half squared minus a quarter. That's going to be really bit of a hassle there, but anyway, no problem, we'll carry on. So this is going to be y equals 4 times x plus a half squared minus 1 minus 5, which is 4 times x plus a half squared minus 6. Now you can't really see a single transformation when you deal with it like this, unfortunately, because it's like what's happened. It's been translated by minus a half to the left, okay, and then it's been multiplied by 4. Okay, then you have you could say a vertical stretch of factor 4. Okay, so it looks it doesn't really, I mean, if you were to draw this graph, okay, it would be exactly the same place as this, actually. There would be exactly the same place, because the vertex here is going to be when x equals minus a half. The vertex here is also going to be when x equals minus a half. So they'll be in the same place in relation to each other. Minus a half, minus 6, and this will also be minus a half and minus 6. So if you were to sketch them, they would actually, of course, they'll look exactly the same because they're the same graph. So if you were to sketch them, you'll be able to see the transformation, okay? That is equivalent, whatever this transformation is equivalent to that, okay? It's equivalent to that transformation. You'd be able to see that. Okay, so if we took the vertex of this graph, which would be minus 1, minus 6, and we carried out this transformation, it should make us end up in the same place as basically what's happening. If you stretch this horizontally by a factor of a half, you will end up with minus a half, minus 6, which is exactly where we end up. The vertex would be in the same place. So it does work, but you can't see it so well here. Well, you can see it better if you do it in this way. But even before that, if you can just spot straight away that replacing the x with 2x will make this become exactly the same as that, then you don't have to go through all of this as well. But I'm just trying to elaborate a bit to show you how they actually end up, these are basically the same thing. Okay, and if you want to express this as a single transformation, then you say, okay, let's try to express this as like a 1 there. Okay, so you could try to do that by, for example, we could have take out here. We can make this 4 times x plus. If we add these together, you're going to have 2x plus 1. Okay, over 2. Right? Because that's going to be x plus a half. Okay, so we can just manipulate a bit so it looks the same as this. So now we can take out 2 squared from this. Okay, so this is like 4 times 2x plus 1 squared over 2 squared. That's the same as that. Minus 6, that cancels with that, and you end up with this. So they're the same thing. Okay, and if you can express it in a way that only one thing has changed, you'll be able to see it. But as I said, the quick way is to just basically realize x has been replaced by 2x, and that's fine. I'm elaborating on this part here because one of my students has asked me about how he tried to complete the square and he probably got this, and he thought that this is a series of transformations, but in fact it's just one transformation. If you plot it, you'll see that you're at the same level, minus 6, horizontally, and it's moved, the vertex moved closer to the x-axis, okay, by a factor of a half. And in fact, this, you can make it look like that anyway. But completing the square, if you see a perfect square, you can complete the square like this is probably better. Okay, so that completes this question. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from this topic of transformations of graphs in this playlist. You can watch some Edexcel transformations questions from this playlist, and you can subscribe to my channel by clicking over there. Thank you for watching, and see you soon.